Hey, what's up, SM3? So we're going to talk about 10.6, which is confidence intervals. Okay. Um, so to talk about confidence intervals, um, let's first give an example of what we are going to be talking about today. So in this first part, so if you're in class, you'll see this, but we'll conduct an example where in the class we'll calculate the mean and the standard deviation of the number of siblings of everyone in the class. Okay, so let's say that we do this if we're in class and we go around class and we see how many siblings everyone has, and let's say that we come up with a mean of so the class mean we'll say as x bar, since we'll compare it with TimView. Um, we'll say that this is the mean is equal to, let's say that we get something like 5. Okay, we are in Utah, so maybe that's about the mean. We'll see. So if we have a mean of 5, and let's say that we have a standard deviation of let's say 2. Let's say 1. Okay, 1 sounds like it might be better. Okay, so if we looked at a distribution, normal distribution of this right here, um, of this information, we'd have 5 right in the middle, right, and then we'd have 4, 3, and 2, and then we'd have 6, 7, and 8, something like that. Okay. Honestly, the mean's probably a little bit lower. That's probably a high mean. But anyways, we're not looking to be too precise right here, okay? So, now, if we use this example of our class, is this class a good random sampling of Timpview High School? Well, to be honest, probably not, because it's not random at all of Timpview High School. It's our class, and so this would be a convenient sample. Wouldn't really be much of a random sample. But in any case, it might be representative just simply due to the fact that um, we live in the same area, so, and same culture, so the population, so maybe people in Provo, Utah have um, they have similar their family sizes, right? Okay, so maybe, I guess we can just say maybe at this point, but just know it's probably not great, probably not the worst at all also, but so is the mean and the standard deviation for Timpview High School the same? So if we did the same experiment for Timpview High School, would we come up with the same numbers though? Probably not. I would say no, we definitely wouldn't come up with the same exact ones. Would they be similar? Our hope is that they are at least similar, that the numbers are at least similar, that the mean is at least somewhat similar and the standard deviation is somewhat similar. So that's our hope, okay? So that's what we're kind of getting at today, is that whenever we do samplings, whenever we take samples from a population, there's always room for sampling error because we're never going to get the perfect numbers, right? There's always room for sampling error, right? So confidence intervals are a way of helping us see how confident we are that our sample represents the population. Okay? So again, if we had the mean of 5 for the classroom, but let's say that we wanted to see how close we are to this school. Well, let's say we're not going to survey the school, but what we want to do is we want to set up an interval, okay? So this is the class mean of 5 siblings for everyone in the class. That's the average. Now, we want to see, we want to create a interval of numbers to maybe say that Timpview High School, that if Timpview, that the mean for Timpview High School is somewhere between this number right here. So today what we're going to do is we're going to learn how we can set up a margin of error around this. So we could say that the population, not the sample, our sample was 5, right? But what we'll do today is we'll set up a margin of error where we think the population is somewhere between this range right here, all based around the mean right here. So we could say that, well, for Timpview High School, it's more than likely not 5, but we're pretty confident that it's somewhere between 4 and 6, or we can say 3 and 7, something like that. So that's what we're going to talk about today. We're going to set up margin of errors. Okay, now think about this concept though. So let's say, for example, that it was 4 and 7, or 4 and 6 right there. Now, if we contrast that to, just to save space, I'm going to write smaller. Okay, so let's say we have the mean of 5 in the class, but for Timpview, let's say that we want to say that it's between 4 and 6. That we're somewhat confident that it's between 4 and 6. But let's say that we want to increase the bounds. So let's say if we had 5, but we want to say that it's somewhere between 3 and 7. Okay? So the thing is, how confident should we be? So this is where the confidence intervals come into play. How confident are we? More confident? Should we be more confident that the actual Timpview High School mean is somewhere in this interval or in this interval? So you would say that you're more confident in this interval and less confident in this interval, because in the one on the right, 3 to 7 covers a wider range. It's a wider interval, and so we could be more confident that the Timpview High School mean is somewhere between 3 and 7. We're more likely to have a mean somewhere between 3 and 7 than we are between 4 and 6, because our interval is larger. So this is where we say that we're more confident in the larger interval, less confident in a smaller interval. Okay, so this is what the idea of a confidence interval is. Okay, so definition, I guess you could say, of a confidence interval is an estimate. So confidence interval is an estimate of a population parameter. Population parameter stated as a range with a specified degree of certainty. Okay, so we'll break this down first. I'll come back to this in just a second, but let's first talk about how to calculate the range. So the maximum error estimate right here, this is the margin of error, okay? This is the margin of error. So there's a way in statistics that we actually calculate this margin of error. So first of all, we say E. So E is the margin of error. Now this is calculated by taking a z-score and multiplying it by the standard deviation, the sample standard deviation, which is S, divided by the square root of n. So z in this equation is the z value, or the z-score. S is the standard deviation, more specifically the sample standard deviation. So standard deviation, and n is the sample size. N is the sample size. Okay, now where does this z kind of come from? That's kind of like where I often ask the question, where does the z come from? The z comes from the confidence interval, okay? So confidence interval, again, it's an estimate of a population parameter stated as a range. So stated as a range means like the margin of error with a specified degree of certainty, right? So like I said, a larger margin of error, a larger range, means you're going to be more confident. And a smaller range means you're going to be less confident. So we state this degree of certainty by saying, well, we can say that we are 99% confident. We are less confident, which would mean we are 70% confident. That's somewhere between there, right? So if we have a larger margin of error, that means our confidence, our degree of certainty is larger, okay? So these are going to be your most common levels of confidence interval of confidence levels, okay? So if we remember our z-value table, okay, our z-value table, now the area under the curve represented the percentage of the curve, right? Now under this curve, if we take 90% of this curve, 90% of the area under this curve from the middle, so the middle 90%, that means you are between the values of 1.645 and negative 1.645. And it's the same thing if you're if it's 95% of the area under the curve. The middle 90% represents the range between 1.96 and negative 1.96. And then if it's 99% of the curve, it goes from negative 2.576 and 2.576, okay? So that's where these levels of confidence come from, right here. So the more confident that we are, the more area under the curve that we cover, okay? So that's where the z-value comes from. So you'll see in these questions, I'll do an example, it's going to ask you to state a confidence interval depending on your level of confidence, okay? Now, so the confidence interval, how you calculate the confidence interval, so we say CI for confidence interval. Confidence interval is where you take the value in question, right? So the sample mean, and you add and subtract the margin of error, which is E. So in other words, what we're doing is for the confidence interval, it's the mean, and it doesn't always have to be a mean. It can be like a median, it could be standard deviation, it can be population size, but for our purposes in this unit, we're just going to be using the mean. And then we know that E is equal to Z times by S divided by the square root of N. Okay, so this is how we make a confidence interval. So again, this is what we did before. So it's like we take 5, right, which was our sample mean of our class, and then what we're doing is we're stating a margin of error that for what the school mean might be. So it might be plus 1 or it might be minus 1, thus setting up my interval between 3 and 6. Okay, so that's why it's plus or minus. So we're taking the mean, which is x bar, and we're adding or subtracting we're adding and subtracting the margin of error, thus creating our range. Okay, so let's go ahead and use these equations down here in this example. So example, a sample of 400 adults was asked the average time spent watching television each weeknight. The mean time was 68.4 minutes with a standard deviation of 20.9 minutes. Determine a 95% confidence interval for the population mean, okay? So we have a sample, but we want to see possibly where the population mean is, okay? So just to kind of give you an illustration, so we have 400 adults. So in this case, N is equal to 400. Now the mean is equal to 68.4, and S, the standard deviation, is 20.9. Okay, so let's make sure that we have all this information accounted for. So the sample mean is 68.4. It's asking us to create a confidence interval of 95%. So we want to say, well, the population mean, not the sample mean, the population mean is, we're 95% sure that it's somewhere between these values. Okay, so that's what we need to find. So next step is to find the margin of error. So let's find E. Now if we go back up here, E is equal to the z-score times by S divided by, I'm going to write it right here, E is equal to S times, or not S, it's equal to the z value times by S divided by the square root of n. So if we're going to use a 95% confidence interval, then we're going to want to use the z value of 1.96. So we'll say 1.96 as z times by S, which is 20.9, from there, divided by the square root of n, which is 400, like that. So this will give me my margin of error. So let's go ahead and calculate this. Now, 1.96 times by 20.9 divided by the square root of 400, which is 20. So I'm just going to do that now. Okay, so let's do 1.96 times by 20.9 divided by 20. And I get, I divided it by 2. So 1.96 times by 20.9 divided by 20. And I get 2.0482. So my margin of error is equal to 2.0482. So that's my margin of error. Now what is my confidence interval? My confidence interval is going to be x bar plus or minus my margin of error. So it's going to be x bar, which is 68.4, plus or minus 2.0482. Okay? Now if you punch that into your calculator, so you have to do both. So you have to do 68. So it's like you're taking 68.4 and then you need to subtract it to find the lower bound, and then add the margin of error to find the upper bound. So if you do that, this is how we state it. We are 95% confident that the population mean is somewhere between, now if you do this, you should get something like 66.35 and 70.45. So we're saying that we're 95% confident that the population mean is somewhere between these values. The sample mean is directly in between them, but the population mean, we're assuming that we're 95% confident that is somewhere between 66.35 minutes and 70.45 minutes. Okay? Alright, now let's try doing something with a different confidence interval. So it says find the 99% confidence interval for each of the following. Okay, so 95% confidence interval for each of the following. So first of all, let me just look that up right now. So 95% is 2.576. So 2.576, that's its corresponding z value. So first of all, we're given x, we're given the sample size, and we're given n. Perfect. Find the margin of error. So the margin of error is equal to the z value, which is 2.576, times by s divided by the square root of n. Okay, so when we do that, let's do 9.2 divided by the square root of 150. 9.2 divided by the square root of 150. So I get 0.75, and I want to multiply that by my corresponding z value, which was 2.576. And I get 1.935. So that's my margin of error. Okay, my margin of error is that. Okay, and so I take my, so now to find my confidence interval, I need to take my x bar value, which is 78, and plus or minus the margin of error, 1.935. So 78 plus or minus 1.935. When you do that, you should get something like, now we usually write this as a, you can write it out as a sentence, that's fine, but you can write it out as an inequality, okay? So what we could say is that 76.065 is less than or equal to the mean population, which would be mu, and that has to be less than or equal to 79.935. So these are the numbers that you get when you add and subtract from 78. Okay, and again, it's the population. Make sure you don't get this confused. We're given the sample mean, but the population mean is what we're trying to estimate, right? It's somewhere between these values right here. Okay, this is our lower bound, this is our upper bound. Okay. Alright, so that's pretty much it for most of these right here. Okay, I'll let you guys go through some of these ones. And then for this one right here, it's pretty much just the same thing. It's just another story problem. Just can you gather the information? So a poll of 388 randomly chosen office workers showed that they spend an average of 1.8 hours not working while on the clock. The standard deviation is 0.6 hours. Determine a 90% confidence interval for the population mean. So make sure we have our information. N in this case is a poll of 388 randomly chosen office workers, so it has to be 388. And the average time, which is X bar that they spend off the clock working, is 1.8, and the standard deviation is 0.6. Okay. Now the confidence interval Z, we're using 90% confidence interval, which is 1.645. 1.645. So use this information, find E, then find your confidence interval. Okay, and state your confidence interval as such. Okay, and that should pretty much do it for confidence intervals. Okay, let me know if you got any questions.